In today's video, we will test the speed of some most popular VPN solutions. We will test NordVPN, Surfshark and ProtonVPN. And none of them sponsored this video. I purchased the subscriptions myself for all those VPN solutions using my own money, and I just wanted to share the results with you. And the test will involve both OpenVPN and WireGuard protocol to see how much faster the WireGuard is, if it is faster at all, I mean. So let's get started. I will go through the testing setup first, so if you are not interested how it was tested and you only want to see the results, then jump to this exact time that will be displayed below right now. And regarding that testing setup, I wanted this test to be focused on VPN speed only, so I didn't want to install some desktop graphical applications, for each of those providers we would have to download and configure blah blah blah. I decided to use Gluetun VPN Docker container. They will be all identical, and the only difference will be the VPN provider configuration on them. So we will have 7 lightweight Alpine Linux containers with curl and SCP utilities, and then we will have 6 Gluetun VPN client containers. And you might ask, why the difference in number of those containers? Well, that's because one of those Alpine Linux will be used to test the speed with no VPN configured for it, so we will see the speed we get when there is no VPN involved. Alright, so let's just jump in. This is my AWS cloud, and if you want to learn more about AWS, just join our Automation Avenue platform, yes? You can learn AWS and other stuff. And I will create 2 Ubuntu instances that will be based in London. In EC2 panel, I just say launch instance, and I don't need 1, I need 2 actually. I can increase it here. Number of instances 2. I will call them whatever, Ubuntu maybe, doesn't matter. But I will choose here Ubuntu operating system. It's fine. We'll scroll down. Instance type, I will choose something with very fast network interface card, like a C6IN. And maybe X large, 4 CPUs, 8 GB memory, but very fast internet connection, 30 gigabits per second, so super fast, alright? That's gonna be overkill, but never mind, I want them to be fast, and they're gonna be fast. Keeper, network settings fine. Storage, we might need a little bit more, maybe let's say 100 gig. I will choose that advanced as well, because we need it to be encrypted. And IOPS 15,000, throughput 1000. We want to go fast. Alright, that's it. Launch instance. We will have 2 instances. 2 virtual servers in the cloud. They are there, we can see them. We can also click this button, view all instances, and we can see them up and running. They will have public IP addresses, so we can open terminal and we can log on to them. I say SSH, default user is Ubuntu, for Ubuntu AMI operating system, and I say add public IP address, which is 35176.221.128. Yes, as the first one, and let's open another terminal. I say SSH Ubuntu at 5256.180.179. This will be the other instance. So we've got 2 instances. And we don't need that background really, we just need the terminals now. And let me maybe clear. I say here PS1 equals client. This will be our client, so we can clearly see what it is, alright? And here PS1 equals, this will be our server. Nice. On the server, I will create a 1 GB file. So I am in home Ubuntu, because if I run who am I am Ubuntu user, so I'm in my home directory, and I will create here 1 GB file. I will use the dd command, which is the easiest. I say if equals dev0, we will write zeros to that file, output file name, I will call it speed test, and the block size will be 1 meg, let's say. But count will equal 1024. That will result in 1 GB file in size. I will run it. So if I run lsl, we can see we've got fresh newly created file called speed test, and the size, I know it might be funny, but it's actually 1 GB size. And that's all we need from server really. Let's jump to the client now. From client, I want to be able to SSH to the server, because then, later on, I will want to run scp command to pull that file, that 1 gig file, over the VPN. So on the client, I need SSH key. I say SSH keygen. That will generate the SSH key. Enter, 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 enter. We can see the key was created here, home ubuntu.ssh, and the ID ed blah blah blah. So I can go to, I'm already in home ubuntu, so I cd to SSH. And if I run lsl, I can see those keys here. Basically all I need to do is to copy this public key to authorized keys folder file here on the server. Let me show you how. I say cat id blah 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 pub. This is my public key. I simply copy that, and on the server I say echo, and in quotation marks I will paste my key, and then I say append that to home ubuntu authorized keys. Press enter, and now I should be able to SSH to that server. I say SSH, and in fact I can choose either private or public IP address and it should work. But I have to use Ubuntu user, so I say ubuntu at 172.3.128.148. Press enter, yes. Yes, of course. Somebody might watch that and say, Marek, you're so stupid. On the server, this location is wrong. Remember what's the correct location of that file? It's home ubuntu.ssh. And then you have your keys and you have your authorized keys as well. Sorry, so let me rerun that command. Never mind, nobody saw that, yes. .ssh. This is correct location, sorry about it. Press enter. Now, hopefully, second attempt. SSH ubuntu blah blah. Yay, look at that. It's the same IP address now. I am on the server. So I can exit. Now I am back on the client. And we can do our first test. Not over VPN yet, but from now, because I can SSH, I can also run a command called scp, secure copy, which uses SSH protocol in the background. Basically what I can do, I can just use the up arrow and we SSH to that server using that command. So I can add a :/home ubuntu, and that's the location where we have our speed test file. So I said speed test, I want to download it, but it's not SSH command, it's scp command. I replace SSH with scp. Now I have to say where to download it. I mean, where I want to see this file here locally on this client. And I say dot. Dot means here, exactly where I am, in this folder where I'm currently in, alright? So I just press enter. What's going on here? pwd lsl speed test. This is wrong, but the speed test is here. Oh, please. It's not my day, you know. You already know what it is, of course you know. It's not speed test, it's speed test. Press enter. Okay, now it works. Look at that. 500 megabytes per second. This time is not very accurate. You know what? We can do better. We can do up arrow, and at the beginning I can add time. It will show us exact time, how long it takes for that command to run, which also means how long it takes to download the file, yes? So I press enter. Bam. It took 2 seconds, 2.3 seconds, 2.4 let's say, alright? That's great, isn't it? But this is like a direct connection between one and the other server, and we are using private IP addresses. But in fact, we can use public IP address. If I go back, we've got both. These servers have private IP addresses and they have public IP addresses. And I can copy them from here, or simply I can, one second, let me minimize. On the server I can also run curl ifconfig.me, and this will also show me public IP address. Ends with 179, if we check, that's the server, 179. Alright, so I will just run up arrow, and then I change the private IP address to public, and I say 52.56.180.179. And now we are connecting to public IP address of the server. Let's see how fast that's gonna be. Press enter. Because we connect to different interface on the server, it will ask this question again. So I say yes, and speed test is running. Okay, this is crap. This included all the time I was talking about this thing. So let me run again. Because we can see 2 seconds here, but 24 seconds there. That's because I was talking about this crap, yeah? So I will run it again, and now it will show me only the time it took for that command to run. And you can see it took nearly the same time as when we used the private IP address. Why is that? Because we never really go out to the internet. In AWS, those servers, to go towards the internet, they will use so-called internet gateway. But because they are both in AWS, when a client sends the query to the public IP address of the server, it reaches the internet gateway, but AWS looks at that and says, bro, you know, this server is right here, next to you. And it bounces it back to the server, you know, so we don't really leave that subnet, the same subnet, right? Even though it's public IP, we don't really leave this little AWS bubble. Anyways, just to double check, if I run LSL, this file is here, as you can see. Oh, alright, we are in in SSH. I thought we are in home directory, we are in SSH, so let me remove that file. Speed test. We don't need it here. Okay, and I will go one up. So now, now I'm in my home directory. We pulled from home directory here on the server, but we pulled it to .ssh directory. Never mind, doesn't really matter. That 2 seconds is really the minimum time it can take to copy that file. We can't really go lower than that because, you know, these servers are next to each other. And by the way, let me improve that command even further. Where is it? Time. We can put it in brackets, for example, and after that I will say end rm speed test. What this will do, it will time only this command, and then after that it will remove the file it downloaded. But this portion will not be timed, okay? So the time will still only be for this first part. If I run it again, you can see that, you know, yeah, 2.49. It was 2.3 or something. Yeah, we can see it's roughly the same time. And some of you already say, Marek, okay, but what about the VPN? Yes? Okay, all right, let's do the VPN now. To create containers and those Gluetun VPN clients, I will use Docker Compose file. And I've got it ready, and I will share it with you. You will find it in the comments and in the video description, both as a PDF and within my GitHub repo if you want. So you can simply download them, and you can run those tests yourself on your machine if you want. So to run Docker and Docker Compose, I need some commands first. I need to run sudo apt-get update and sudo apt-get upgrade. Yes, auto yes. This is done, so maybe let's clear that. And now I say sudo apt install docker.io and docker compose. So we will be able to run both Docker and Docker Compose commands. That's done. Last, it's not important, but I say, who am I? I'm Ubuntu, yes? I can add this user to the Docker group, so I don't have to run it as sudo, like sudo docker blah blah. Instead of that, I can say sudo usermod ag, it's capital G, docker, and whoever my user is. My user is Ubuntu, so I say Ubuntu. And now I do new grp docker to restart that group, and you can see it will kick me out. It removes that client thing, yes? I have to run it again. ps1 equals client. It kind of restarts this session. But at least now I don't have to use that sudo anymore. Right, that's cool. Now we are ready to use the Docker Compose file. And as I said, I've got it ready. I will go through some of the bits and bobs in that file. And if you want, you can simply copy it using that PDF or GitHub repo in the comments. The links will be there. But basically what I have to do is, let's make sure, where am I? I'm in home Ubuntu, that's fine. So I say vim docker compose.yaml. I will create a new file called dockercompose.yaml. Press enter. It's empty file, so let me just copy it now. Paste. And let me just give you a quick overview what it is about, alright? At the top we have services, and this is the list of our services. First one is NoVPN container. I called it NoVPN because it's the standalone container. They are all Alpine Linux based. The name will be for this one NoVPN. And this is simple command I will paste, I will run at the time when it's created. It will simply add OpenSSH, so it's able to run SSH and SCP commands. It will be able to run the curl command, and sleep infinity is just so it runs in the background, and I don't have to worry about it. That TTY is so we can connect to it, and these volumes, the thing is, this container needs SSH keys to be able to SCP to the server, yes? And we already created SSH key, but it's on the host, on the Ubuntu host. So what I'm doing here, I'm copying that SSH key to the container, to the root.ssh location on the container. And please note that this is not what you normally would do. Normally you would probably want to create a new key for each container, for every single container. This is what I did just for testing purposes, but this is not a good practice, and it simply shows just how lazy I am, you know. I created one key, and I will copy that one key to all of the containers, because every single container, if we scroll down to NordVPN OpenVPN, you will see it will use the same SSH key, it will pull it simply from the host. And because it's already here in authorized keys, well, not here, that was the wrong location, so if I go to cd SSH, can't type today, what's going on? LSL. This is the authorized key file. And it already has this SSH key that we have on the host. So every single container will pull that key, will put it in this location, so it can use it then to SSH, to SCP the file from the server back to the container. But what's that NordVPN, OpenVPN, etc., yeah? What is it about? Well, this is the service. I called it NordVPN OpenVPN. You can call it whatever. That's simply, I wanted to distinguish them. So NordVPN is our provider, and OpenVPN is the protocol we are going to use for our VPN. The image we use Alpine Linux, and the network mode will make this container to route all the traffic to a service called Gluetun 1. And Gluetun 1 is just below. This is the service. So basically everything that this container does, the traffic that it will, you know, when it's pulling the file from this server, it will simply go through that Gluetun. And that Gluetun is configured to use NordVPN with the VPN type of OpenVPN. And those funny things are environment variables that I will talk about shortly. You simply have to have some credentials, OpenVPN user, OpenVPN password. If you open an account with NordVPN, you will get that OpenVPN user and password. I will not go too far, but simply we will have to set that user and password as environment variable. And we use that name for our environment variable. It's called NordVPN OpenVPN user and NordVPN OpenVPN password. And the last one is server cities. It's also configured as environment variable, so we can easily change the location where our VPN tunnels will terminate for all of those containers at the same time. So if I go further, I've got NordVPN WireGuard. Again, the service is called whatever the VPN provider is, and then the protocol used, WireGuard. So I have NordVPN WireGuard, the same name for container name, but this service goes through service Gluetun 2. And the Gluetun 2 is here, just below. It's kind of the same portion. And the Gluetun 2 looks exactly the same, except of the fact that it's configured for VPN type WireGuard, which is different protocol. It's supposed to be faster, it's newer protocol that we can use for our VPN connections. And WireGuard uses that WireGuard private key. And by the way, it's not that easy to get that WireGuard private key from NordVPN. I even created a video. It's actually the previous video that I decided to create. So if you want, you can watch it to see how you get WireGuard, private key for NordVPN service. But the last variable, server cities, it's the same variable for every single Gluetun container. So if we change that, we will change where the VPN terminates for all of those containers. Then we have Surfshark OpenVPN. Surfshark will use Gluetun 3 for the OpenVPN solution. And we can see the provider is Surfshark, VPN type is OpenVPN, and the environment variable is called Surfshark OpenVPN user. But this one is again the same, it's just city. We have Surfshark WireGuard, ProtonVPN OpenVPN implementation, and ProtonVPN WireGuard implementation. Hope that makes sense. So I just save this file, :wq in vim, press enter, and if I run lsl, this file is in my home directory. So now I can run docker compose app-d, and I will run that entire docker compose file. Press enter, and let's wait. Oh, okay. I can see one mistake already. Another one today. Sorry about that. We forgot the most important thing. Never mind. Let's say not up, but down. Docker compose down. Let's destroy everything. You can see the warning. NordVPN variable is not set, defaulting to blank string. Of course, it's not set because I forgot to do that. Basically, all those variables I was talking about, environment variables, here on the host, let me clear that. What I mean, it's if we check that docker compose file, if you, for example, obtain WireGuard key for ProtonVPN, you can simply paste it here. Rather than using those environment variables, you can simply paste it here. I only use that because it's not the best practice to hard code any credentials, in the file, especially the file that I want to share later on with you. What if I forget to remove that data? You will get all my keys and, you will be able to access everything that I can access. So it's easier and safer to use this instead, rather than pasting the actual key. And then on the host, I can just paste them all like that. I say export, and then each value that these Docker containers need, I have to provide them here. And you can see the city, I set it to London. So let's press enter. All the values have now been exported. So let me clear again. I have to make sure I blur this information, it's very important. These are all the keys that you would have to obtain from your VPN providers. I cleared that, and now I can run docker compose app-d again. This time it should work, hopefully. Okay, looks much better, doesn't it? I can say docker logs Gluetun. Let's see. I mean, it might be too quick. Oh, no, it's not. Already it says this is the IP address of the server, and we can see that server is located in London. Let me clear. Cat docker compose. I just want to check. Gluetun. This is Gluetun. Aha, so it's for NordVPN OpenVPN implementation. I can check also logs for Gluetun 2. We can also see it's in London, etc. If I check Gluetun 3, we will see different IP address, because that one was for Surfshark, I think. But the location is still in London. And we can check them all like that. Maybe 5, let's say. Again, different IP address, but the location stays the same. But what I can do now, that's the most important thing, I can log on to my container. I say docker exec -it, the name of the container, I say NordVPN OpenVPN, that was the first implementation, and sh, I want to connect to shell. That's it, and I can run our command. And I forgot what it was. Let me exit it, and let me just check the history. I will grab for time. Oh, it's not here, sorry, because we reset the entire terminal. Yeah, okay. Docker exec, our command was time scp ubuntu at public IP of the server, curl if config me gives me public IP of the server, and the location was home ubuntu speed test. I want to download it here, and I want to remove it afterwards. Speed test. Is it correct? Speed test, yes. Let's run it. See, 60 megabytes per second. It's pretty decent, isn't it? But it's also much slower than it was before, because now we are going through the VPN connection. It's pretty short VPN connection, because we are only going from our servers through the Gluetun. To remember, our city is set to London. So this will be first server in London that NordVPN allowed us to use. So it simply goes from AWS to NordVPN. The traffic then goes back to the server with no VPN. It goes back to NordVPN server and then encrypted again over VPN tunnel, it goes back to us, to this container. And you can see it took 21.8 seconds. And this is for NordVPN for OpenVPN implementation. And this is exactly how I'm going to test all of those, Surfshark and NordVPN and ProtonVPN over OpenVPN and WireGuard implementation. So let me say exit and let's compare to NordVPN WireGuard. That's the other container that will use WireGuard implementation. Let's see if it will be quicker. And this time I will just copy it because I'm lazy, you remember. Press enter. That's it. And we just wait. And it looks like, wow, it is faster. It took just 5 seconds and we can see 223 megabytes per second. So that's like what? More than 4 times faster. That's interesting. Alright, let's exit. And let's check now. I say, what was next one? Surfshark. Surfshark OpenVPN. I will paste my command, press enter. Let's see what that takes. I can see it's roughly comparable to NordVPN, around 45 megs per second, but let's see. Slightly slower, but you know what? It's a negligible difference. Let's exit, and I say now Surfshark, but WireGuard. We connect to that container. We run the same command again. You can see it's faster, but it's not as fast as NordVPN was. Although 8 seconds, it's still decent. This one was 5 seconds, this one is 8 seconds. So let's exit and let's see what ProtonVPN has to say. OpenVPN option, paste, run. It's 38, 39, 50 meg. Okay. Oh, it starts slow and then it increases the speed. Wow, took 14 seconds. But that's for OpenVPN, remember. It took 22 seconds for Surfshark and 21 seconds for NordVPN. Interesting. So, oh, no, that's not what I want. I want to exit and I want to check WireGuard implementation. Paste, run. That's quite interesting, isn't it? WireGuard took longer than OpenVPN. Let's maybe run it again. Yes, pretty consistent. 17 seconds. So let's exit. Let's go back to OpenVPN. Let's see if that's right. Yes, OpenVPN seems to be much faster than WireGuard, which is unusual, I would say. Okay, but what I can do now, London is very short, distance. Let's see how it behaves on longer distances, that VPN. Because what I can do now, simply on my host, let me clear again, on my host, I can simply say export city, it's variable city, equals to what? Let's say Dublin. Let's maybe not, don't go very far, like geographically immediately. Let's see what happens when I change it to another country. Dublin is in Ireland. It's not that far, but it has to cross the borders. And if I run that, I changed that for every single container. But to make it implemented, I say docker compose down. And now I say docker compose up-d. They are recreated, but now if we check docker logs, for example, Gluetun 1, look at that, it's Ireland now. And maybe, I don't know, 6, yeah? I will not go through all of them. But yes, it's also Ireland. So that works as expected. And I will run those tests, all those tests again, but for this new location. And this time we can see it took nearly twice as long as it previously did. We had 20 seconds, I believe. So let's exit, and now the WireGuard. Why isn't it running? What's going on? Let's see. Okay, I rerun docker compose up-d. Let's see. NordVPN WireGuard. Now it works. A little hiccup, I guess. Never mind. Let's check the speed test. WireGuard is decent though. You can see 13.58 seconds. Okay, so let's exit. And I say, what's next? Surfshark. Surfshark OpenVPN, at least implementation, seems to be much slower. Took 58 seconds. Alright, so let's exit and see what WireGuard says. "20-second, decent. Exit. ProtonVPN. Let's see if this connection also is faster than WireGuard. Remember, for ProtonVPN OpenVPN was faster than WireGuard implementation. Let's see if that happens here as well. So far it's decent. 37 megs over OpenVPN is good. So let's exit and see what WireGuard says. For some reason, this time WireGuard is faster. Honestly, that's what I would expect for London as well. Not sure why London was slower than Ireland. Maybe you have explanation. I don't have explanation for that, I don't know. Let's run it one more time, just to see how consistent it is. And it looks already that it is consistent, because we've got 50 megs again. Yes, 19 seconds. This one was nearly 18, so it is consistent. Alright, let's exit. Let's set new location. I say, what? Something far. Export city equals what? Los Angeles, maybe. But if you have space, you better add those quotes, you know, because otherwise you will only have first word. Let's press enter, and you can also check. If you say echo $city, you can check what currently is kept in that variable. And we can see it is Los Angeles, so that's cool. That's what we need. So I say again, docker compose down. Let's bring all the stack down. That's done. And now docker compose up-d. And let's run it again. If no, okay, they are up to date now. Remember last time NordVPN moaned about something. Doesn't really matter. Let's just double check. Docker logs and Gluetun maybe number 4. What's going on here? It is Los Angeles, California. Perfect. So we test everything again. You can see it's going to be slow, because even it starts slow. But remember, we are going through entire world now. We are going from London to Los Angeles, back to London. The file is picked up, and part of it is pulled, I mean, back to Los Angeles, and then again to London. So, you know, at those distances, it's not only the performance of the VPN really, it's also the networks, all the path between us and the whatever, you know, providers are between us and Los Angeles. Don't always blame the VPN provider. You would have to run this test really several times, and if something is really bad, maybe even on the following day, to see if it was really a VPN issue or if it was one of the service providers issue. So we have to be fair, yes. But let's see what it looks like now. But this should be a very easy way to run those tests whenever you want. Just download the file, that Docker Compose file, and you just change the cities. Or countries. You can change that also to country rather than city. But country is... I picked the city because country, for example, United States. What do we connect to? Is it West Coast, East Coast? It's pretty vague. I decided to be more accurate. That will take a while, so I will just fast forward all of them. 5 minutes 43 seconds, yes, but well, that's something I can understand. Let's see if Wireshark is much better. Not Wireshark, but WireGuard. I think I will simply use up arrow, because I make too many mistakes today. Okay, so that's interesting, because that WireGuard, it looks like it can cut the time spent in half. We had 5 minutes 43, and look at that, 2 minutes, it's nearly exactly half of the time. So that's good news. Alright, let's exit and see how Surfshark will perform. Okay, looks like did pretty well, a bit faster than NordVPN. So let's see the WireGuard implementation. And now let's check the Proton. And last but not least, let's check the Proton but with WireGuard. Anyways, all those tests, I guess you already have the idea. It's not as easy as, we can't have like clear conclusion, oh, this VPN provider is the fastest. As you can see, it depends on which implementation you take. Is it WireGuard, is it OpenVPN, and depending on the location, etc. In my opinion, they are all good. These speeds, they are good. For VPN provider, I would simply go with the cheapest one. That's my honest opinion. Whoever has the best offer right now, it will do the job. As you can see, it will differ. For example, one will be a little bit faster here, and the other one will be faster there. But it's not like one absolute winner that smashes all the competitors. But I hope that at least you find it interesting, and if you download the file, you can perform the tests yourself, maybe with other VPN providers, and maybe you can share it with us in the comments. So alright, let's see how ProtonVPN WireGuard does. And it completed. And it is faster than OpenVPN implementation on longer distances, so I don't know what happened in London, but you have an idea of what what ProtonVPN performance is like. Okay, so we've got the results, we can see what it is, what it looks like, and if you have maybe a better idea how we can measure the VPN speed even better way, then please let me know in the comments. And also remember to join Automation Avenue platform, where you can learn more about AWS Cloud, about Linux, about Python programming, etc. There are hours and hours of stuff there that you can, they might be really, really helpful for you, I believe. So I hope to see you next time, and thank you for watching.